Hello, I'm Wavid Bowman from DuPont Manual High School, and this is my science fair project. The effect of type of electrolyte in an electrochemical cell on the amount of charge in an electrochemical cell. Imagine you're in a natural disaster situation, and you are in charge of deciding what type of battery the disaster relief team is going to use for their flashlights. You need to decide what type of battery will have the highest total amount of charge. It's so vital that you choose the battery with the highest amount of charge, because if you don't, then the rescue team will run out of power faster and will be able to save less people. The decision of what type of battery to choose and the lives of the people are on your shoulders. It's in this exact type of situation that's the reason why I decided to research this topic. Not only will knowing what type of battery has the most amount of charge help in emergency situations, but it also helps in mundane situations, such as what type of battery you should use in your alarm clock or in fire detectors. Batteries work by generating electrical energy in the electrolyte, usually using a chemical reaction. After electrical energy is generated, it sends that energy through the anode into the circuit. That energy then travels through the circuit, going through the devices that are connected to it, which act as resistors for the electrons. Then the circuit is completed, ending in the cathode. The design was decided to measure the variables in the experiment over time consistently, as shown in the picture. The materials used were alkaline 9-volt batteries, lithium-ion 9-volt batteries, zinc-carbon 9-volt batteries, 2 multimeters, a breadboard, and the miscellaneous cords and connectors that would be needed to set up this experiment. How I did this was I set up the breadboard to where it would create a complete circuit going through the voltage multimeter, a 30 ohm resistor, and a current multimeter, using whatever 9-volt battery I used as the power source for the circuit. What I did is I connected each 9-volt battery and I measured the current and voltage every 12 minutes, and I repeated that until all the batteries died and all the values were recorded. The data found is shown in these charts and graphs. What was found was that, on average, the lithium-ion battery had 5,742.72 coulombs of power. The alkaline battery had 2,815.92 coulombs of power. The zinc-carbon battery had 250.56 coulombs of power. The most plausible reason for these findings is that because of the differing chemical reactions used to get electrical energy, caused the differing longevity of the batteries and therefore the different of overall charge. This connects to prior research on the subject, which is rather sparse because nobody researches 9-volt batteries. But a study by the Department of Energy found that batteries of these types usually had an accelerating rate of charge decay and then a sudden end of life, as shown by the data that I found as well. Further improvements for this project could be to test different types of electrolytes, or to use different size batteries with different numbers of cells. Knowing this information, what type of battery will have the most total amount of charge, could help you decide what to use in that rescue situation. If you choose the lithium-ion battery, the rescue team now knows that their battery will last the longest, and you will definitively just be able to decide to use the lithium-ion. This could help save This could save the time that running out of charge would lose, saving dozens of lives. The charges were found by measuring the area under the curves of each of the graphs. This was done using the trapezoidal method, which does not detract from the overall accuracy of the experiment because of how the data was collected. Any questions?
Yes, so why is the resistor a light bulb?
The resistor is a light bulb because it not only acts as a 30 ohm resistor in the experiment, but it also gives a visual indicator on whether or not power is running through the system.